Let's now start with the next video related to cryptography. And here we will be looking at what we call public key cryptography. We will be looking into some different possibilities, the things that are existing today, before we continue with some more, let's say, examples. First of all, when we look at private versus public key cryptography, we have to say that what we previously described was what we called a private key cryptosystem. And in a private key cryptosystem, everybody has to have the key to be able to decrypt the messages. Now, when we look at a shift cipher, when we have an encryption key K, it's in fact that the encryption is done by adding K and shifting the characters by K characters, and decrypting is done by shifting the characters in the other direction. Now that's in fact very interesting to know, but if you want to decrypt a message that you receive, you have to know that key. So you have to be able to call or to calculate C, the encrypted character is P plus K modulus 26, and in fact to find P again we have to say C minus K modulus 26. But it's very important that both parties basically have the key available. Now, when we want to share those secrets, the need to have the key is important, because we have the necessity to understand how the encryption was done. So without the private key, we cannot do anything. And the fact that we may be very vulnerable when that key is in fact detected, it is also possible to find ways how to share the keys and change them without sending them to the people, let's say, or by giving them in person. So the system can have a key that is exchanged by parties even over the classical open communications or over telephone, fax, or whatever communication method we are using. Now, when we look at the modern encryption standards and the public key cryptography, we had the DES and the triple DES cryptosystems. Now, we already said that even the DES is in fact a cryptosystem which became vulnerable. It was replaced by triple DES, but even later with the new standard, the EAS or the Randall cryptosystem. Now, basically what's happening here is that when we are looking at all those different elements, we have to look at that standard. And the DES standard was basically introduced in the 1970s, developed by IBM, and was used as a main encryption protocol. Now, this is a symmetric block cipher, uses the same key for encrypting and decrypting, and it uses a 56-bit key. Now, over the time, it was easy to decipher the messages because the modern computers became, let's say, so powerful that this was obsolete. Some even say that there was a backdoor, that there was a possibility to find out what the messages were, even when you didn't have the key. Now, they included everything in a 3-DES alternative, triple DES, which was at the time used when I was working in AT&T. It was one of the protocols to share information. And what we also noticed that in certain countries, triple DES was not allowed, only DES was allowed. We can wonder why, but I have some clear understanding that when somebody doesn't allow a certain encryption system, it means that they cannot read the messages. So basically, we have to understand what is happening in the world of encryption. And even legal governments, certainly illegal organizations would like to know what you're doing, and you have to be careful about the things you do. Now, let's say the new system that has become the standard is what we call the encryption standard, or the advanced encryption standard, is also called the Rijndael. Like I said before, it was developed by two Belgian mathematicians, and they use a 256-bit key, which makes it at this moment unbreakable, but we can assume that there will be ways to find it. Computers are getting more and more powerful, so basically what we may want to do is to find a better algorithm, a better encryption standard to take into account the powerful computers that are existing today. One of the things you can in fact do is to be sure that you change the keys at regular intervals. For example, you can calculate the theoretical time to break the encryption, and you can say, well, I will replace the keys as half that time, and that time can also be set whenever you want. So you can adjust the system, make it stronger, like what the Germans did with the Enigma machine. They added some more wheels, they changed the encryptions faster, so it becomes more difficult to decrypt the messages. When we look at the public key cryptography, now we have to share it between the different elements. And what is happening with the public key cryptography is that we want to share the keys. We want to use different encryption keys for every session between parties, and we want to require, or we want to have a method to generate these keys and share them in a secure way. And public key cryptography plays an important role here. Basically, what we know is that in the 1970s was that the people, or some people, introduced what they call a public key cryptosystem. And during that time, or from that time, it was possible to share decryption keys in a secure way. So basically, I encrypt a message. For my counterparty to decrypt it, they have to find the decryption key, and we use a public key cryptosystem to share the decryption key with the receiving party. So basically, people can find out how to decipher a message. Now, we know that we are sending an encrypted message, and the way that you can decrypt it, we know how to send a message. That's one thing. Now, on the other hand, we don't know how to decrypt that message. So when we send a message, we also have to send information to the, let's say, to the recipient, the intended recipient, so that they can find a way to decipher the message. Now, in the public key cryptography, the encryption keys are public, but the decryption keys are secret, and they are shared between the parties using a special protocol. We will look at that protocol at the end of this series of videos related to cryptography. That was what I wanted to say about the secret, the private, and the public crypto systems, or the keys, and we are going to look further into the next video into a very well-known crypto system, which is the RSA crypto system. I remember using this crypto system when I was in AT&T. I had a typical generator, a little LCD display which was showing a code which was changing every minute, and with that code it was possible to set up a secure IP tunnel with the servers of AT&T. And it's quite funny because one day I was in Paris, I forgot my crypto key, and I had to ask somebody to read the numbers where they were. Of course, they didn't have the other elements available. For them, those numbers didn't say anything. But if they would have had my computer together with that crypto system, or with that, let's say, that little device, it would have been possible to access all my information. So it's very important to keep that element separated from everybody. Anyway, you're doing a great job, and I'm looking forward to seeing you in our next video. Thank you, and bye-bye.